Hello, welcome. In this short video, let us look at an example illustrating the multinomial probability distribution. That is, when you have n independent trials and each of the trial has k possible outcomes with corresponding probabilities P1, P2, P3 up to Pk, such that the sum P1 plus P2 plus P3 and so on up to Pk is equal to 1. That is, the total probabilities is 1. So, in this situation, that is, each of the trial, out of n trials, each of the trial has k possible outcomes. So, out of these n trials, we can clearly claim that out of these n trials, x1 trials will have outcome 1 and x2 trials will have outcome 2 and k trials will have outcome k. That is, x1 plus x2 plus xk is equal to n. So each of these random variables x1, x2, xk will basically sum to the number of trials n. Then the probability distribution or probability mass function of these k random variables is given by probability mass function or the probability distribution of these k random variables that sum to the number of trials n is given by the multinomial distribution. x1, x2, xk is equal to n factorial by x1 factorial, x2 factorial and so on up to xk factorial multiplied by p1 power x1, p2 power x2 and so on to pk power xk. So this is the multinomial distribution. The probabilities p1, p2, pk sum to 1. And the range for the values x1, x2 up to xk, they belong to the interval 0, n such that their sum x1 plus x2 plus and so on to xk, that is I equal to 1 to k of xi is basically equal to n, the total number of trials. So the range for the values of x1, x2, xk is between 0 to 1, 0 to n. The marginal distribution of xi of xi, that is one of the k random variables, that is fxi of xi, is a binomial distribution with the parameters n and pi. That is, fxi of xi is given by n factorial by xi factorial into n minus xi factorial multiplied by pi power xi into 1 minus pi power n minus xi. So this is the marginal probability distribution or marginal probability mass function of the one of the random variables. The probability of x1 equal to a1, x2 equal to a2 and so on up to xk equal to ak is given by n factorial divided by a1 factorial up to ak factorial multiplied by p1 power a1, p2 power a2 and so on up to pk power ak. So this is the probability of the following event. And finally, the probability of one of the variables, say x2, say less than, probability of x2 less than m, where m is less than n, is given by the sum I equal to 0 to m minus 1 of the binomial distribution. The binomial distribution of the parameters n, p2. So the probability of the one of the variables is given by the sum of the marginal distribution from 0 to m minus 1. So to conclude, when there are n independent trials with k possible outcomes, then the probability distribution, that is the joint probability mass function of the k random variables, is a multinomial distribution. Thanks for watching.